About the test, I want to thank these people. I want to thank Shadrach. Shadrach almost got 100%. Got, I think it was 97. I want to thank Amera. Amera got something like 93. Was it 93%? That was very good. There was another person who registered the name as Jack Oyot. Ever Jack? I will find out. So Amera, Shadrach, and that person. Thank you very much for reading and concentrating. Yes, scoring above 90, it is not easy if you are not doing serious work. For those who have just joined, I have begun by thanking those who did very well, who did excellently actually, those who had 90 and above. I've been thanking Amera, I've been thanking Shadrach, and there is another person who registered the name as Jack. Is it Onik? Onik. Yes, a name which looks like that. Those people had above 90. Shadrach got 97, almost 100%. That was very good. I want to thank people who improved. So there was a very, very great improvement. So improved. I think he had 60 something. Tina Katiti also improved. She was above average. Then there are these people who declined. This is Merisha. Yeah, Merisha, thank you so much. You are the one who registered as Jackie or Ayot. Thank you. It was a good performance. Then there are these people who declined. Number one is Gorova. Gorova, that is not how you are supposed to be performing. You are 100% material. You got 50 something. Glory, you also declined. That is not what I expected from you. So let us keep on working hard and taking these classes seriously. Read the notes that we discuss. Take out important points, most especially when I'm explaining here. Endeavor to always write a summary of the important points. So without wasting time, let us look at the corrections. They are the only ones we are going to do today. I hope you have somewhere to write, but you don't have to write a lot because I have written the corrections for you. After the lesson, I will just send them. So just pay attention. We have lithium, potassium, and sodium. They belong to the same chemical family. We have lithium, potassium, sodium. They belong to the same chemical family. The question is, state the group to which the elements belong. The answer was the elements belong to group 1. These elements belong to group 1. And the reason why they belong to group 1, many of you are writing very weird answers. The reason is only one. An element will belong to group 1 only if it has 1 electron. An electron will belong to group 1 if it has only 1 electron in the outermost energy level. So that was the reason. A group half mark. and reason half mark also. State the general name. I had forgotten to write the word name here. The general name given to the elements. Elements of group 1, we said they are alkali metals. Called them alkali metals. Alkali or alkaline metals. That was correct. And group 2, those who remember, group 2 elements, we called them alkaline earth metals. So group 1, they are called alkali metals. Why do we call them alkali metals? Because most of their compounds, if it is an oxide, it becomes an acidic oxide. If it is an oxide, it becomes an acidic oxide. If it is a hydroxide, it becomes a base. So that's why they are called alkali metals. Then group 2, we are saying they are called alkali earth metals. So that was the general name. The general name is that they are called alkali metals. I don't know why you are still failing this question, you people. I don't know. I don't know. I don't know how many times I've told you to concentrate on this. Up to now, you are still failing. This question, please, sodium naga wangenda kukubira mu ndakiika 3. Sisobola. Anti mpamu endakiika 3 zokka. State what is observed and write an equation in each case when a piece of sodium metal is burnt in limited oxygen. You people, come on. When sodium is burnt in limited oxygen, the product is sodium oxide. And sodium oxide is... Who can tell me the color of sodium oxide very fast? Joy. Who can tell me the color of sodium oxide?
White.
Sodium oxide is a white solid. And sodium peroxide? Sodium peroxide is a yellow solid. Masava, I see you were ready for it, but let's move on faster. Sodium peroxide is a yellow solid. But in all these two, the color of the flame formed does not change. The color of the flame still stays yellow. So in both cases, I told you when a question asks you to state what is observed when a substance is burnt in oxygen, it can be sodium, it can be magnesium. Mention the color of the flame. It can be hydrogen, it can be sulfur. So sodium burns with a yellow flame, whether in excess oxygen or limited oxygen. Potassium burns with a purple flame or lilac flame, you people. Calcium burns with a red flame. Magnesium burns with a white bright flame, forming white ash or white solid, which is magnesium oxide. Hydrogen burns with a pale blue flame, forming a colorless liquid, which is water. Then the equations apply. Sulfur burns with a blue flame, forming a colorless gas, fumes of a colorless gas, which is sulfur dioxide. How long do you want us to just go to your notes? And I told you those reactions with oxygen are very important. So B part 1, our answer should have been, and you see what I have underlined, you see what I mark. I told you a question asking you to state what is observed when a substance is burnt in air. The answer is you give the color of the flame and you give the color of the solid formed at the end. So sodium burns with a pale yellow flame, forming a white solid. And this was in limited oxygen. Our equation is here. Amela, you did not read the question properly. The question said state what is observed and write the equation. For you, you only stated what was observed. You didn't see the equation part. And I think that's the only thing you failed. You lost three marks for the equation. You don't know how heavy 3 marks are at this time. So sodium plus oxygen, the product is sodium oxide. Then to balance, I told you begin by making oxygen an even number. So you put 2 to make oxygen atoms 2. After all, they are already 2 on the left-hand side. And when you do that, the sodium atoms become 4. So you need to put 4 on sodium. So this was the balanced equation. In excess oxygen, sodium burns with a yellow flame. The color of the flame does not change. Please give the color of the flame and the compound formed at the end. Okay? Sodium burns with a yellow flame, forming a yellow solid. And the yellow solid this time is sodium peroxide. Now in this case, the oxygen atoms are already 2, and the oxygen atoms are to this side. So you only balance sodium by putting here a what? A 2. And that is the balanced equation. Maybe some of you keep forgetting the formula of sodium oxide. Sodium uses a valence of 1. That one, you know how it comes about. Just write the 20 elements and write the electronic configurations. Whereas oxygen uses a valence of 2. Let us go to part C. Part C was very, very interesting question. Can you imagine how friendly I was to you? I wrote for you these 2 equations and I wanted you to complete and balance them. Now, when sodium is dissolved in water, this time I realized that you have crammed the observations very well. So I wanted to test you on the equation part. And I think I got you. Yeah. So when sodium dissolves in water, it forms a hydroxide, sodium hydroxide, and hydrogen gas. However, remember we said magnesium does not react with cold water or reacts slowly with cold water, but it reacts with steam. So that's why the state of water there is what? Is gas. And when magnesium reacts with steam, the products are magnesium oxide and hydrogen gas. So here we are. Sodium plus water, the products were sodium hydroxide plus hydrogen gas. We have written this equation many times also. To balance, I told you, always begin from oxygen. Make it an even number. So I had to put here a 2 to make oxygen atoms 2. But however, when I put there a 2, the hydrogen atoms on the left hand side, on the right hand side, become 4. So I have to put 2 on water to balance hydrogen. And that was the equation. And when I put, then the sodiums were already 2, so I also put a 2 sodium, like that. Magnesium plus water, the product is magnesium oxide plus hydrogen. Magnesium oxide plus hydrogen. You know what we said about that. And who can tell me the observation here? Very fast. Observation. State what is observed when steam. Let's begin like this. Conditions. What are the conditions for this reaction? Faster, you people. Faster, faster. We don't have a lot of time. Someone tell me what are the conditions for this reaction and what will be observed. I don't like it when I ask a question and you don't answer. This is a class, we should all be participating. Karen, are you giving me the answer? Now, when I ask Karen to give me the answer, she just unmutes. The conditions for this reaction, please, we said magnesium must be heated. So, steam is water gas and it is passed over heated magnesium. We said the magnesium will catch fire and start burning with a bright white flame, forming white ash or white solid, and the white solid is magnesium oxide. Let us go to part D. Part D, we have elements W, X, Y, and Z. So W is 12 atomic number. That means electronic configuration is 2 to 8 to 2. X is 6. That means configuration is 2 to 4. And Y is 17. That means configuration is 2 to 8 to what? 7. So the first part of the question, which was asking you to write the electronic configuration of W, whose atomic number was 12, the electronic configuration was 2 to 8 to 2. And for Z, the electronic configuration was 10. No, the atomic number was 10 for Z, as you can see. So its configuration was 2 to 8. Now the type of bonding formed between X and Y. Clearly, X, when you look at the electronic configuration of X is 2 to 4. It has 4 electrons in the outermost shell, so it is a non-metal. It is not a metal. And the electronic configuration of Y is 2 to 8 to 7. That means it will have 7 electrons in the outermost shell. Clearly, that's not a metal either. So the type of bond is covalent. Using outermost shell electrons, show how a compound is formed between W and Y. W is 2 to 8 to 2, it is a metal, and Y is 2 to 8 to 7, which is a non-metal. So the type of bonding here is ionic. We have spent some good time doing that. Those of you who tried to do it correctly, I want to thank you. But my question was using the outermost shell electrons. So you had no reason to put in the innermost shell electrons. And for those who put in the innermost shell electrons, I think I denied you the marks. So when the question says use outermost shell electrons, be sure to use only the outermost shell electrons. So W has 2 electrons in the outermost shell. When we write its electronic configuration, 2 to 8 to 2. Then Y, 2 to 8 to 7, it has 7 electrons in the outermost shell. W can lose 2, but Y can gain 1. Since W can lose 2, that means you should have 2 structures of Y. And that's what you are seeing, such that each structure of Y takes 1 electron. And when that happens and W has lost all the 2, it will not have any shell, but we shall put 2 positive charges to show that it has lost electrons. I want you to look at your work which you presented. Most of you, I was not supposed to give you my marks. The arrow should have the origin. Can we see where the arrow is coming from? Some of you, you are moving the arrow from here. You see where I have marked, where I have highlighted. You move the arrow from here. The arrow must be seen to be coming from the electron. It is this electron you are transferring from W to Y. And again, when this electron is transferred, you don't put it there immediately. Should you put X here, then you must put a negative charge. So that's why we wait and put X this side, such that we put it together with a negative charge. We put it together with a negative charge. Okay? So we shall have 2 structures of Y where each one has gained an electron, and that is it. So the charges cancel out each other. These are 2 positive, and these ones are also 2 negative. 2 times negative 1, 2 negative, and we cancel each other. Feel free to ask any question if it is there as we move on. When we look at this, when we look at the formula formed between X and Y, X was 2 to 6 and Y is still 2 to 8 to 7. So these are all non-metals. And the compound formed is a covalent compound. I missed to put here a plus, but you can put it. Many of you were showing transfer of electrons. In covalent bonding, we should not see any arrow. In covalent bonding, it is only sharing of electrons, whereby if you have 4 electrons which are not paired for X, that means each one of them must pair. So you create 4 structures of Y, and each structure of Y comes where there is 1 electron, and the electron for Y pairs with this one. So this first one pairs with that first one, then that second one will pair with this, and this one will also pair with this, and finally we have our compound where X is the central atom or is in the middle. When you count, each atom must have 8 electrons, each one of them. And finally, where there has been sharing of electrons, there will be a covalent bond there. That is our compound. The question was saying state YZ is generally unreactive. The atomic number of Z was 10. So the electronic configuration was 2 to 8. So that compound will be unreactive because it has 8 electrons in the outermost shell, and the maximum number of electrons is 8. So when an atom has 8 electrons in the outermost shell, we say it is already stable. So that atom cannot gain, and nor can it lose electrons. So the answer was its outermost energy level is fully filled with electrons, or it has 8 electrons in the outermost energy level, which is maximum. Therefore, it's stable and does not lose or gain electrons. Simple as that. We are going to number 2. Number 2 was a very simple question. There is no one who failed this. A normal salt and an acid salt. For a normal salt, we are saying all the ionizable hydrogen of the acid is replaced by a metallic. However, some of you are just saying is replaced by a metal ion. No, write the definition the way it is. All the ionizable hydrogen of the acid is replaced by a metallic or ammonium ion, e.g. sodium chloride. Sodium chloride comes from hydrochloric acid. Then acid salt, where part of the ionizable hydrogen of the acid is replaced by a metal or ammonium ion, e.g. calcium hydrogen. Yeah, please, when you should always move away from your young brothers and sisters at home. That's how you end up being disrupted. You don't listen to me properly, and when I give you assignment, you fail. Take these classes seriously. Now, this question was very simple because I had given it to you some time back as an assignment. I wanted to find out how many of you I wanted to find out how many of you do assignments and revise. Some of you, you crammed this answer here and you gave me the answer when you had not plotted the graph. I was also very serious, so I refused to mark that one. You should plot the graph first before you give me the answer. So the graph, you can also plot it later on, and this is how it comes out. This is our graph. So the first question after plotting the graph, please look at the scale. Plotting should not be a problem to you by now. When I say 2 centimeters to represent 10 units, it means I get 10 and divide by the number of small squares which are 10, and I get 1. So each small square here will count 1, 1, 1. When I said 2 centimeters to represent 20, I get 20 divided by 10, and each small square will count 2. So the first question was, determine the solubility of this salt. Your graph should have scale, it should have axes, and on the axes you put the units. So determine the solubility at 35. I told you, you draw a line at 35 degrees centigrade until it meets the curve, and you move and look for the solubility. The solubility was 54 grams per 100 grams of water, but I only marked those who had the graph. Some of you got 55, others got 56. I think I also gave you the mark. The other question was, you find the mass of potassium nitrate that saturates 25 grams of water. If solubility at 35 is 54, remember the definition of solubility, it is the amount of salt required to saturate 100 grams of water. Amount of solute required to saturate 100 grams of water. So if solubility is 54, then it means 100 grams of water dissolve 54 grams of potassium nitrate. Then 1 gram you divide by 100 both sides and you get 54 out of 100, and 25 you multiply by 25 degrees centigrade. There was another question but which I didn't ask you. This question was asking you to determine the mass of crystals deposited when a solution is cooled from 65 to 25 degrees centigrade. So you first get the solubility at 65 and the answer is 122. Then you also get the solubility at 25 and you subtract. Mass of salt deposited is always the solubility at higher temperature divided by solubility at low temperature. So that was it for the graph. I want us to look at this question, which almost all of you failed. You people, I told you, you cannot prepare a salt when you don't know solubility rules. The first question that should come into your head is the salt soluble or insoluble? The salt you are preparing this time is a carbonate, zinc carbonate. Is zinc carbonate soluble or insoluble? The answer is it is insoluble. We said all carbonates are insoluble except sodium, potassium, and ammonium. Those are the only 3 carbonates that are soluble in water: sodium carbonate, potassium carbonate, and ammonium carbonate. So zinc carbonate is insoluble. How are insoluble salts prepared? Insoluble salts are prepared by precipitation or double decomposition. What is precipitation? Precipitation is where you react 2 substances which are soluble to get one that is insoluble. So whoever attempted to use zinc oxide, zinc metal, 0. You don't score. You are preparing an insoluble salt. You should look for 2 salts where one is soluble and another one is insoluble. I told you, if you are preparing zinc sulfate, I mean zinc carbonate, you know all nitrates are soluble. So you react zinc nitrate and then to get a carbonate, you know sodium, all sorts of sodium are soluble. Add sodium carbonate. So substances to use, you could have used right away zinc nitrate because all nitrates are soluble, and sodium carbonate because all carbonates are of sodium are soluble. All sodium salts are soluble. So if you don't know, if you fail to get the 2 substances that are reacting together, you get 0. And I was telling you, we use zinc nitrate. You can even use zinc chloride, but we use nitrate to simplify our work because all nitrates are soluble. And this is the same question we did the other time in the other test, only that by then I gave you ready 2 carbonate. Same technique. So put zinc nitrate in a beaker and add solid sodium and add sodium carbonate solution. When you do that, you'll form a white precipitate, and the white precipitate you form, that means it has not dissolved there. That's why the method is called precipitation, because you are preparing a salt that is insoluble in water. It does not dissolve in water, so you should form a precipitate. But a precipitate forms when you react 2 substances which are soluble, and they form an insoluble salt. So filter the precipitate. When you filter, you always get a filtrate and a residue. You are interested in the one that does not dissolve because you are preparing an insoluble salt. So you wash the residue. Eh? The residue is the one you want this time. The filtrate is the one that dissolves, so you don't need it. So you filter, wash the residue with distilled water, then dry the solid residue by placing it between two filter papers, and you will be done. I told you you must write an equation there. Our equation is zinc nitrate. Remember the valence of zinc is 2 and nitrate is 1. Zinc nitrate plus sodium carbonate, and the product, zinc will take the carbonate and sodium will take the nitrate. So you form zinc nitrate plus sodium what? No, zinc carbonate plus sodium nitrate. So sodium has a valence of 1 and carbonate has a valence of 2. So that's why sodium carbonate is like that. So you must put a 2 here to balance sodium nitrate. That is it for today. Can I have some questions if they are there from what I have explained? If there are no questions, I'm sending you the corrections such that you do them in the remaining time. Today, I'm not giving you assignment. I want you to first concentrate on these corrections and pass them. So on Monday, I'm likely to give you questions related to what I have discussed with you here on corrections.